it in front of me, I guess. The domain range paper that I passed out first.
Oh, shoot!
Oh, you scared me.
Hey, it's for your pencil.
Okay, so
Wait until Tyler go back to his desk.
Tyler, go back to your desk.
Oh my freaking goodness.
All right, that's the paper I want you to have out.
Ask me to come over here though. He needs help.
So we're not doing really new concepts. It's just been a while since we talked about some of these. Okay, to talk about the folder, just again, because I know a few people were absent. When the EOC is over, I will collect your folders and you will get grades for them. One for writing on them, like the stuff I had you write on it today, plus for all the contents inside. Because I want to make sure that you have everything inside of there that you're supposed to have inside of there, and that everything inside of there has been completed. Okay? Like today's paper, I'm going to actually grade that for accuracy, and then I'll give those back to you, and you can then put them back inside your folder. Okay, everybody have this paper? I passed them out earlier. Okay, so this is just kind of reviewing domain and range. So domain is the set of all, what do you think? X. Domain is the set of all x's, also the first coordinates. Because when you have an ordered pair, the x comes first, the y comes second. I passed them out when you guys were working. I passed them out. They should be on your desk.
No, mine's not like that though. I'll take this one.
Well, I put 3 on your desk. 1 for you, 1 for Zach, and 1 for Peter. Okay, range. These are your set of all y's, or the second coordinates. And then there's a few other things I just want to say before we move on. Domain. If those are your x's, are those independent or dependent?
Yes. Independent.
Independent. You would have written it on your folder today. Your domain are your x's, and your x's are independent. So domain are x's, and the x's are always independent. Range, those are your y's, and those are dependent. So just some stuff I kind of wanted you to know that we talked about a long, long time ago, but we really haven't talked about it since. Yes, this will go in your folder. These are like notes for the day, but it's like review kind of notes, and they will go in your folder. And when the EOC is over, I'll pick up your folder, and this is a paper I'll look for. Your Algebra 1 one is May 6th. Okay, if I had this equation, and I'm just making up an equation here, whatever variable is by itself, and it could be this. Let's see. Let me just write it this way. Yeah. I don't care what the equation is, but whatever variable is all by its lonesome, that is always the independent or dependent. What do you think?
Independent. No,
Dependent. The one that is by itself is always the dependent variable. Your cost depends on how many hours. Your y depends on whatever x is. And the variable that's mixed in with all the other stuff, that's the independent. So it's just not always x and y. So that's why I wanted to throw a different letter in there, because it's not always x and y. Sometimes there are other letters. But the variable that's all by its little lonesome, that's your dependent variable. And the letter that's mixed in with the other stuff, that's your independent variable. So these are things that I'm trying to get you to shove into your brain, and hopefully you'll remember for the next 2 weeks. So y depends on x. Cost depends on hours. Okay. If you ever just see a set of ordered pairs, that is called a relation.
On the test, is it going to have like questions like that?
Well, it may say something like, look at the relation below and blah blah blah. And some students might be like, relation? So it's just the word might get thrown in, and you may not know what it means. So like this right here, this is called a relation. They may say something like, is the relation below a function? Well, if you don't know what relation means and you don't know what function means, and you see a question that says, is the relation below a function, that might make you go, what? So a relation is just any set of ordered pairs, but then a function is when the x's do not repeat. And we saw that in a question on one of the worksheets last week. So a function is when your x's do not repeat. Okay, so number one. If I want to list the domain, I want to list my x's, and I do want to put them in order from smallest to largest. So what do you think they are?
0.
Like if I go from smallest to largest, though?
0, 0. Oh.
What's this? Domain.
Negative 10.
Yeah, negative 10 is the smallest x you see, and then?
Negative 8.
And then?
Negative 5.
Okay.
0.
Okay.
5 and 2.
There we go. So domain are your x's. The x's are the first numbers in the set of ordered pairs, and we do list them in order from smallest to largest. Even though this 5 repeated here, we don't repeat it in the list. Okay, range are your y's, and I'm going to list those in order from smallest to largest as well.
Negative 4.
Negative 4.
Negative 4.
Negative 3.
Good.
Negative 2.
Good.
2.
There's something else.
0.
0.
0. 2.
Good.
4 and 8.
There we go. So range or y's, those are the second number in the ordered pairs, and we list them from smallest to largest, and we don't repeat them.
Okay, do y'all hear that?
Yes.
You heard that?
Yes. Okay, is this a function? Is this a function?
No.
How come? Yes. This 5 right here repeats. If x's repeat, it is not a function. This is like you going to McDonald's and ordering a number 5, and the cashier gives you back $3 for ordering it, and someone else orders a number 5 and has to pay $2 for it. So you can't order the same meal and have it cost different amounts. So if x's repeat, it's not a function. Okay, number 2. Since these are just random ordered pairs, the domain is going to be a list of numbers again, and the range will be a list of numbers. So domain are your x's. What is your x clear over here at this far left point? Negative 3. And then what's your x at this one? Negative 2. What's your 0? 1 and 2. So whenever you just see a set of random ordered pairs like that, your domain is going to be just a list of numbers, and your range is going to be just a list of numbers. Okay, so range, I want the y's, so I'll be looking up and down this time. So what is the y for both of these?
0.
Both of these have a y value of 0, right? It's not off of the x-axis, so the y is 0. This one's not off of the y-axis, or x-axis, so the y is a 0. Okay, what's the y for this one? 2. What's the next y? 3. And the next y? 4. Is this a function?
Yes.
Yes. No matter what vertical line you draw, you will only cross one point. As long as you only cross one point, then yes, it is a function.
Wait, did you go in order?
Yes, I went from smallest to largest, so I who's
Oh my
doing that?
gosh, what is that?
What?
Do y'all not hear that?
That's
That ringing, that's an iPhone notification.
You're going crazy, bro. I heard that too.
Nobody's going crazy.
Like super high.
We can hear it.
Aliens are back. Oh god.
Okay, this right here is called a discrete graph because the points are not connected. So if points aren't connected, it's called discrete. If your graph has points that are connected, so points are connected, no holes or jumps, then that's called continuous. And these are words that we would have talked about earlier in the year. It's just been a while. So if you just see random ordered pairs, there's jumps in the graph or there's skips in the graph, that's called discrete. But if you see a graph that's smooth, there's no holes, there's no jumps, then it's called continuous. Something like that. That would be considered a continuous graph. Something that's smooth, no holes, no jumps. Okay, let's flip it. Are you ready?
No.
You want the other one?
Alright, I'm ready for that. We need to go.
Ready? Ready?
Wait, no, not the flags.
Well, what were you ready for?
Now I'm ready.
For the flip?
Yes.
Okay. This one is a smooth graph, so this is considered to be continuous. So if we have a continuous graph, our domain and our range is not going to be just a list of ordered pairs. Earlier in the discrete graph, our domain and range was just a list of ordered pairs. If we have a smooth, continuous graph, the domain and range are going to be written as an inequality. So domain, x's or y's? X's. My x's are running left and right. What's the farthest left we have?
-7.
-7. What's the farthest right x we have? +4. And then I have to fill in these symbols. As I start cruising this way, are my x's getting bigger than -7 or smaller? So I have to put the big mouth facing the x. Do you know if it's going to get an equal sign?
Yes.
Because of the closed circle, it's going to get an equals. Okay, and then when we're over here at the x value of 4, if I start cruising this way, do my x's get bigger than 4 or smaller? So I have to put the pointed end facing the x so it says the x's are smaller than 4. So this is the kind of domain and range we write when we have a continuous graph. If it's nice and smooth. Okay, range are your y's. So this time I want to be looking up and down. What's the lowest y we have? 0. What's the highest y we have? 6. Okay, and do my y's get bigger than 0 or smaller? So I need the big mouth facing the y. Will it get an equals?
Yeah.
Okay, and then do my y's get bigger than that 6 or smaller? Smaller, so pointed in facing the y, and there's no equals on those because that was an open circle. Is that a function? Yes. No matter what vertical line you draw, you will only cross that graph once, so yes. Okay, I want to do number 4 and number 5 in the calculator. We could definitely do these by hand, but I want to show you some calculator things as long as I possibly can. So I want to go to the y equals of the calculator, and I want to type that in. So let's go to y equals and type in 3x minus 4. Okay, on this one I want to look at a table, so I'm going to go second graph. Okay, when it gives me this over here, that these are the range, these are the what? These are the y's. So I need to be looking for these numbers in the y column. So let me look for -7 in the y column. And there it is. When you see -7 in the y column, what's the x that goes with it?
-1.
-1. Okay, when you see 2 in the y column, what's the x that goes with it? 2. And do you see the answer? B. So real easy way of doing domain and range, if you just put that in the y equals and go to the table. So since it gave me the range, I had to look for those in the y's. If it would have given me the domain, I would have looked for those in the x's. Okay, number 5. It says if the domain of this function is a set of all real numbers, what's the range? I'm going to draw a rough sketch of this before I actually put it in the calculator. Do you know what it's going to look like? You should have an idea. It's x squared. X squared is a quadratic. What do quadratic graphs look like? They're U-shaped. They're parabolas. Do you know what this -3 makes your parabola do? It makes it start down 3. And do you know, does this parabola open up or does it open down? It opens up. If it's a positive number in front of the x squared, your parabola opens up. So this is just a rough sketch of it. But if I had absolutely no clue what it was going to look like, I could type in x squared minus 3 in the calculator. I could type the x squared minus 3 in the calculator, hit graph, and you can see it for yourself. So if you had no idea what it might look like, you can always verify with the calculator. Okay, so this wants to know what is the range. So range are about your y's, what's happening up and down. What's the lowest y you see? -3. And if the y's keep on going up, 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 what would you say? B. the y's are greater than or equal to -3. The lowest y you have is -3, and then because the graph is going up, 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 up on both sides, then the y's are getting bigger than -3. Okay, let's hop to number 7 real quick because we can do that one faster than 6. On number 7, domain are your x's. What would you tell me the domain is for this picture? All real numbers. The graph goes forever to the left. The graph goes forever to the right. So domain is all real numbers. Range are your y's. What do you think about that?
I think it's the same.
Does the graph go forever up? Does it go forever down? Okay, it does go forever down, but it doesn't go forever up. What's the highest y you see? The highest y you see is 4. And then if the graph goes down, are the y's getting bigger than 4 or smaller? So we say y is less than or equal to 4. The highest y you have is 4, and then it's all the y's smaller because it's going down, 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 down. Is this a function?
Yes.
Yes. It passes that thing called the vertical line test. No matter what vertical line you draw, you would only cross the graph once. Okay, number 6. Carlene sells magazine subscriptions door to door. She receives $4 for each subscription sold. The greatest number of subscriptions that she has sold in 1 hour of working is 5. Which of the following is a reasonable range of her hourly earnings? So I'm trying to figure out what her hourly earnings could be. So she's selling magazines. What's the greatest number she sold in an hour? The greatest number she sold in 1 hour is 5. So what if she sold 0 magazines? How much money would she make? 0. What if she sold 1 magazine? How much money would she make? $4, because she receives $4 for each subscription. Okay, what if she sold 2 magazines? $8. And if she sold 3? 12. If she sold 4? 16. If she sold 5? 20. Has she ever sold more than 5 in an hour? So I stopped. This right here is my range answer. Where do you guys see it? Okay. All right. You have 2 things to do tonight. You have the one I gave you yesterday that I said was due on Wednesday.
Oh.
Remember? And then you have this one that goes with today's lesson, the domain and range practice. Most of it, it should be on your desk. I passed them out earlier. I put 3 there.
You stole mine.
Most of this is multiple choice. Neither one of those papers should take you very long. And I'll probably give you 5 minutes when we get to class tomorrow in case there's a couple that you need the calculator for. So tomorrow you've got this one that you need to have done, and you need that page 7 and page 8 done that I gave you yesterday.
That sounded so big.
You turn the paper where you did the stack button. Yes, I picked those up. Can you guys please put the markers back in the marker boxes? And I'm going to come pick up those markers so my geometry doesn't mess with them. So please put the markers in the marker boxes. Don't just let them roll on the floor.
She's not going to tell you. It's so deep in the dark. I know.
No, you probably why am I not allowed to know? I do not have to say now.
Your friends and everyone.
You got to tell everybody everything.
How's Sydney?
Oh, that's how you do it.
Yes, ma'am.
Just like that, no, we'll stay.
See you guys. Have a nice day.
Oh, Kenzie!
I'm leaving you. Bye.
You said we're waiting on Savannah. See, we have to have a talking.
Bye, Brooklyn. Bye. Don't walk with Savannah.